missing angle measures from triangles. This is actually very useful in the real world for using angles to measure the height of things that we don't know their actual height. So we are going to be using this for some real world problems, but for right now I'm just going to talk to you about just standard trig ratios, what they are, how we're going to set them up. So a trigonometric ratio is a ratio of the lengths of two sides in a right triangle. And that's just what this is saying right here at the top. And so if we're looking at these pictures right here, they have labeled an angle in this first triangle, and they've labeled it with theta, which is a Greek letter here. They've labeled angle A. And if we're going to label the parts of this triangle in reference to angle A, what they're talking about is the parts that they want us to label are the sides. They want us to label them as if they are opposite from A, if it's the hypotenuse of the triangle, and if it is a side adjacent to A. Now the hypotenuse is always going to be adjacent to the angle that you have marked, but it is specifically a hypotenuse, and you need to make sure that you label that one because it's special, being the hypotenuse. Now, we know from Pythagorean theorem, we're used to finding the hypotenuse. Across from the right angle is always where the hypotenuse is at. So I labeled my hypotenuse. Now I'm just down to these other two sides of the triangle, and I'm going to label them as if they are opposite from the angle theta, angle A up here, or if they're adjacent to it. So what I like to do is I always label the hypotenuse first, and then I go to angle that I'm using. And I always circle the angle that I'm using because I need to really be aware that that's the angle that I'm using for reference. So across from this reference angle, opposite from it, the side that doesn't touch it. See how this is angle A and the only two other letters in this triangle are BC? That's the side opposite from it. So it would be labeled opposite. There's only one side left. That third side would be labeled adjacent to this angle because see how this side, it's beside the angle. It is actually, creates part of that angle, and that is adjacent to it. So I'm going to go over here to this other triangle, and I'm going to label that this angle is the reference angle for this triangle, and I'm going to label its sides. So the hypotenuse over here, let's label that. And generally, I don't write the whole word. I'll just write H or HYP and, ADJ for adjacent and OPP for opposite, or just the letters A, O, and H. So I labeled the hypotenuse there. And then across from that angle, opposite from it, not touching that angle at all, is this side. This would be the opposite side. So it is opposite from that angle. And then the last one, and I don't know why, I just always label the adjacent last, because to me, finding the hypotenuse and the opposite side are the easiest. This would be the side adjacent to this angle. So now I've got them labeled, and labeling them is extremely important for solving the problem because you're going to be given one of the sides and you're going to be asked to find one of the sides. And you need to label what those two things are because you need to use them. And depending on which two things you're using, if you're using the hypotenuse and the opposite, or maybe you're using the adjacent and the opposite, the ones that you're using will determine which function you need to use. Now, the sine function is one of them that we're going to use. We're going to use cosine and we're going to use tangent. And they abbreviate them like this. Please don't call that sin. That will drive me crazy. It's short for sine. It's funny. It's like one letter shorter, right? Not that much shorter, but that's sine of the angle, and here it's just theta that we're using as a placeholder. And that is the opposite over the hypotenuse, and that's the ratio that represents the sine of the angle. The cosine, abbreviated as COS, please don't call it cos. Cosine is adjacent over hypotenuse. And then the tangent, TAN for tangent, is the opposite over adjacent. Now, some people like to think of ways to memorize this phrase, or they might have a phrase that helps them. They might memorize how to spell this at the bottom. I am a terrible speller. This week we call it SOHCAHTOA. Some people can spell that out and they can memorize the word SOHCAHTOA and be able to spell it right. Me, I would mess up when I'm spelling that. So I memorize a saying for this, and it's just really a dumb saying. And if you want to make up your own saying, you're more than welcome to. You can share it with me if it's school appropriate, and if it's not, you can just keep that to yourself. But here, the way that I have it set up in ratios, which just helps me because it's supposed to be a ratio when you're using it. So that just helps me to have it already set up. So I say a saying to myself, and I know to set up this sort of, shape in the letters, which represents how they look in the equation. So the way that I was told is some old horse caught another horse taking oats away. And that's really corny, but it worked for me. One of my students once told me that they thought of a phrase, and it was some old hippo caught another hippo tripping on algae. So you could just come up with, whatever phrase helps you to remember this for when we're testing. And what you'll do is you will write this at the top of your paper every single time that you're working any of these problems. Because I don't want you to think about this constantly. I want you to think about it, write it down, and then have it to refer back to. So you'll have to memorize it. It might be on your formula chart. We'll have to look. But for pre-AP, you'll probably need to memorize this for sure. So think about a saying that will help you to remember those letters so that we can set these problems up.